This is video 6 for Chemistry 2, Unit 1, Intermolecular Forces. So in this video, we're going to look at ranking intermolecular forces based on the strength of attraction. So with this, the strongest intermolecular force that we have covered are ion-ion, and I'm going to abbreviate that II. If you do that on any tests, worksheets, I know what that is, so feel free to do II for ion-ion. The next strongest one is going to be hydrogen, which we can abbreviate with an H, then dipole, and then dispersion. So those are the abbreviations that we can use. Now to help us rank these, we know that ion-ion is separated from the other three. So if I draw a little demarcation here, I know that these are going to be ionic compounds, and all of these over here are going to be polar compound, or not polar, they're going to be covalent. We can keep the polar there because we're going to use that here in a second. So hydrogen, dipole, and dispersion are all covalent compounds. We can separate covalent into polar and nonpolar, and that is right here. So nonpolar are going to be dispersion forces, and hydrogen and dipole are polar. We know that covalent compounds have Lewis structure. So if you see a Lewis structure for something, then you know it's covalent. If it's symmetrical, it's nonpolar. If it's not symmetrical, it's polar. The only distinction we have to make is between hydrogen and dipole then. If we have a covalent polar molecule, we have to look to see, does it have H bonded to either fluorine, oxygen, or nitrogen? So if we look at these practice problems, we're going to have two sets of practice problems. This first video is going to go over the first set. So with that, we have water, CCl4, NH3, and then we have two on the next page that we'll go over. I did not print out the Lewis structures, but on worksheets you will have access to Lewis structures for these compounds, but I'm just going to draw them very quickly here. So if it has one, I'll draw it. So there's water, CCl4, and then NH3. So if we look at water first, we have a Lewis structure. So we know that it is covalent. All covalent molecules have dispersion forces. So I can write DISP for dispersion. If I look at the Lewis structure, then I know that we have two hydrogens, two lone pairs. If we have any lone pairs, 1, 2, or 3 lone pairs, it is not symmetrical and it is polar. All polar covalent molecules have dipole. Then I have to see, do we have a hydrogen bond here? Do I have hydrogen bonded to either F, O, or N? And I do. So this has hydrogen bonds. It has hydrogen, dipole, and dispersion. The hydrogen bond is the stronger of them based on our ranking up here. So that's the one that's really going to come in play. It basically masks these other two. So hydrogen bonding outranks all of these. It's the strongest. If I look at our second example, here we have CCl4. Here's its Lewis structure. It has a Lewis structure, so it's automatically dispersion forces because all covalent molecules have dispersion forces. Then we look to see, is this polar or nonpolar? So we have carbon with 4 of the same thing around it, so this is nonpolar. So the only force present on nonpolar covalent molecules is dispersion. So that is by default the strongest. So I'm going to circle that. Down here we have nitrogen. If you'd like to pause this video, try this one by yourself, and then come back and check it, you can. Pause the video now. So this one, we have a Lewis structure. So we know that it's covalent. So it's dispersion. We have a lone pair. That means that it's polar. So we have dipole-dipole. And then we check to see, do we have hydrogen bonded to either F, O, or N? And we do. So we have a hydrogen bond. So that is the stronger of the three. Now, if we move to our last two examples, I'm going to change number 4 to KBr. So make sure that you change that. I know it says CH2O, but KBr is not going to have a Lewis structure. We know that K is a metal, so this must be ionic. And ionic compounds, the only intermolecular force is ion-ion, and that is the only one, so that is the strongest. And then our last one, CO2, I'm going to draw its Lewis structure. It has a Lewis structure, so it's covalent, so we have dispersion forces. And if we look at symmetrical, we don't have any lone pairs on the central atom, and these two things are opposite one another, so it's symmetrical. So this is the strongest force present.